This video was brought to you by the ILC.
Hello there once again. Welcome back to our Exam 1 review. This time we'll be doing problem 8a and 8b, where we are asked to find the local and absolute extrema. Let's start with the local extrema. We are looking for local minimums, and we are also looking for local maximums. Now, local minimums will appear as if they are valleys on the graph, and local maximums will appear to be peaks on the graph. So to find our local minimums, let's look for the valleys. We have a valley here on the left side at negative 3.16, comma, negative 2.25. We can record that as our first local minimum. Then over here on the right, we have another one. So we can say that is 3.16, comma, negative 2.25. To find our local maximums, we look for the peaks, and we have one here in the middle at 0.4. So that takes care of our local extrema. Once we found all of the peaks and valleys, we've got it taken care of. For the absolute extrema, we are looking for the lowest point overall, then the highest point overall. So for our lowest point, we can see that we have two of them. We have 2 points that both have the same y value at negative 2.25. When you have a tie like this, we have to give both of them as our absolute extrema. So it turns out the absolute extrema are exactly the same as the local extrema in this case. Generally that won't happen, but it has this time. Now for our highest point. We did have a local max at 0.4, but we can see from the up arrows that the rest of the graph goes much higher than 0.4 because it goes off to infinity. So we can say the highest y goes toward infinity. Therefore, there is no absolute extrema, and we say does not exist or DNE. So that takes care of the absolute extrema and the local extrema. Building on the marks we've already made on the graph, we can now find the intervals where the function is increasing and decreasing for problems 8c and 8d. The first thing we could do is draw a number line. And I will place stars on the number line based on the locations of the local extrema that we marked previously. Make sure that you use only x values though. We are no longer concerned about the y values when we're just finding increasing or decreasing intervals. So I'll put a star here, and I'll mark it with the x value, negative 3.16. And then another star at 0, using only this x value, and another star at 3.16. To find if the interval is increasing or decreasing, we are going to go from the left to the right. And then look at what's happening to y. Now these stars are going to break our number line into regions. I'll place dotted lines to show where the regions start and end. We will also place our infinities on the line. We'll have 4 regions, A, B, C, and D, as marked by the dotted lines. So let's look at region A, which is everything before this first star. So start from up here where I've made the mark, and go from left to right, down to the first star. So as we move from left to right, we can see that this piece of the graph to the left of that star, if we are moving from left to right, is going down, which means we are decreasing. Now let's look at segment B. As we go from the first star to the second star and we move from the left to the right in this direction, we can see that the graph is moving upward. Therefore, we say B is increasing. Now for region C, which starts at 0 and ends at 3.16, as we go from left to right, we are moving downward. So we will say this is also decreasing. And then for region D, as we go from 3.16 and go off to the right toward infinity, we can see that our line is moving upward as we go from left to right. So that will be increasing. So our decreasing intervals are going to be region A union region C. And our increasing intervals are going to be region B union region D. So to write our regions, we use parentheses around each region. Region A goes from negative infinity to negative 3.16. Union region C, which is 0, 3.16. The increasing intervals are B and D. So for B, we'll say negative 3.16, 0, union 3.16, infinity. That is how we find our increasing and decreasing regions. Now problem 8e is to find the zeros of the function. The zeros of the function are where the graph touches the x-axis. We have 4 places on the graph where that occurs. At negative 4, negative 2, 2, and 4. We do not count 0, 4 because it's not touching the x-axis, it's touching the y-axis. We only need these 4 marks that I've made. So I will say that x equals negative 4, negative 2, 2, and 4. 0 is not on the list. Just those 4 will be the zeros of the function. And that's all you'll have to do for this. We won't have to look at any local minimums or local maximums when we find the zeros. This is completely separate. Thank you for watching. We'll see you again soon.